Hey everyone, it's Mrs. Wallace. I just wanted to do a short video for the topic of consumer theory. This is known as utility maximization. Remember that consumers are really driven to maximize utility, so always think of consumers, as separate than producers. In consumer theory, we're very interested in consumer demand, why there's a relationship between price and quantity demanded, for example. And one of the things that explains that is the theory of diminishing marginal utility. And within that concept, we can play around with utility maximization. So that's what this is all about. On AP Classroom, there's a free response question in Unit 1 that relates to this topic. So after watching this video, just make sure you're doing the AP Classroom multiple choice and AP Classroom free response questions. So in looking at utility theory, there's a few things that we want to consider, okay? Always look at this from the perspective of the consumer, and the consumer is making decisions based on two things. One is total utility. Total utility is the goal of the consumer. We're looking to maximize total utility. If utility is satisfaction and I'm going to have slices of pizza, I know that I am going to be interested in maximizing my total utility. So that tells me I might get more utility from having more slices of pizza. At some point, I might be less interested, right, in pizza. We know it's not a static thing, but my goal is always to maximize my total utility. In an effort to do that, one thing that I can use is by looking at the decision making on a marginal basis. Everything about marginal analysis or marginal cost versus marginal benefit is really all about trying to ensure every single time you take the next good or you have the next slice of pizza. On the producer theory, we looked at what happens when producers produce the next product. Think of the word next as really, really key in marginal thinking, okay? And when we think of that word next, keep in mind that for every next consecutive slice of pizza, right, I have the first pizza, my utility in total is going to be 8 utils. If I have the second slice of pizza, in total, I might have 14 utils. So clearly the second slice of pizza made me additionally, satisfied, right? I feel like my utility has increased. And I can look at things from a marginal level as well. On a marginal level, my utility has increased 6 points, right? It's kind of like 8 points here, 8 points here, and 6 points here, right? From 8 to 14 is 6. 14 to 19 is going to be 5, okay? 19 to 23 is going to be 4, okay? And so on. Something we'll notice is that if I am consuming the first slice, the second slice, the third slice of pizza, my total utility is increasing and increasing, okay? Every next slice of pizza is raising my total utility up until the point where I really have the 7th slice of pizza. At the 7th slice of pizza, I am not increasing my total utility. My total utility has peaked, and at the 8th slice of pizza, that's like my limit. When I go to eat that 8th slice of pizza, my total utility actually declines, okay? And we do see that on a marginal basis, going from the 6th slice of pizza to the 7th slice of pizza, my marginal utility is 0. Going to the 8th slice of pizza, my marginal utility is actually negative, okay? So what this is telling me is that your total utility can be increasing. I can have increasing and increasing amounts of utility from every next slice of pizza, but my marginal utility is actually starting to diminish right after the first slice of pizza. I have the first slice of pizza and my marginal utility goes from 8 to 6. With the second slice of pizza, my marginal utility has decreased, okay? Doesn't necessarily mean I will stop eating pizza when my marginal utility decreases. It depends on if my marginal benefit or marginal utility is decreasing. It depends on what the marginal cost is. I will keep consuming pizza until my marginal benefit is equal to my marginal cost, okay? So in this case, note that we have a pattern. Total utility can be increasing while marginal utility diminishes. Total utility can peak while marginal utility is 0, and total utility can decrease when marginal utility is negative, okay? And if we entertain this question, let's look at this in the next slide. What will pizzas, how many pizzas will I buy, or how many slices of pizza would I buy if the price per slice was $2? So clearly, this is a short slide. If the price of so here's my marginal utility. Okay, so I have exactly the data that I was kind of noting before. My marginal utility is decreasing up until the point where it peaks and then it goes negative. If I was graphing that, I could showcase that. Your marginal cost, on the other hand, is constant. Okay, the marginal cost is the same. It's $2 every single time you eat a slice of pizza, right? So I know, am I going to consume the first slice of pizza, right? The first slice of pizza costs me $2, but I get, 8 utils from it. I'm going to consume it. Will I consume the second slice of pizza? Yes, because I get 6 additional utils, right? Bringing my total utility to 14, but I have 6 additional utils and the price is only $2. I will do the same with the third and with the fourth, because in every one of these cases, that additional piece of pizza is giving me greater marginal utility than it is costing me per slice of pizza. When I get to the fifth unit of pizza, that becomes significant because I notice my marginal utility is 2. I'm getting 2 utils for that next slice of pizza going from the fourth to the fifth, and I also can see that my cost is $2. If I were to try to consume the 6th slice of pizza, I won't, because I only get a little bit of benefit. I get 1 util and it costs me $2. It's that moment where you just say, no thanks, I'm good, right? That's kind of what you're saying, right? My marginal cost has just outweighed my marginal benefit and I'm never going to consume that, okay? So always consume until marginal cost is equal to marginal benefit. And marginal benefit, some cases you're not given marginal benefit or marginal utility, same thing. You have to then derive it from total utility. So like all things marginal, you will continue to consume to marginal benefit equals marginal cost, okay? And marginal cost, again, may be constant, and if that's the case, then you'll use that information. Marginal benefit, however, and of course marginal cost doesn't have to be constant, but say that it is, marginal benefit is not constant, right? It's always going to be diminishing at some point. It may increase at first. You may have something where a next unit of a good actually increases your utility, but at a certain point, because of the law of diminishing marginal utility, we'll expect marginal benefit to decline. This just brings us to the next thing, and this becomes partly related to the free response question that's on AP Classroom for this particular unit, okay? And that's Unit 1. We're looking at now a consumer who is deciding to purchase 2 goods, okay? So say that now we decide Pavit is going to be going, out for a Saturday, and it's either the movies or it's go-karting, right? And we could ask Pavit, which one do you like better? And for this case, right, we have a situation where we're looking at the first time, the second time, the third time, the fourth time. So maybe these are, quantities of go-kart rides or quantities of movies. And let's assume it's like the same movie over and over and over again, okay? Pavit has a marginal utility, and in this case we're not given total utility, but you could figure that out if asked, like if Pavit had seen the same movie twice, went to the movies twice, what would be his total utility? Well, it would be 50, right? How do we know it's 50? Because he has 30 utils from the first movie, and then the second time he saw it he got an additional 20 utils, right? So my total utility is really summing up my marginal utility. I also might look at, let's kind of figure out marginal utility. What does that mean? It's really just telling us how much Pavit likes going to the movies and also how much Pavit likes going go-karting, right? And at first value, if I just look at on a Saturday morning, he's going to decide which one he's going to go and do. I would think, well, Pavit's just going to go to the movies because he clearly likes the movies a lot better than he likes go-karting, right? He gets 30 utils from, the movies. He gets 10, utils from go-karts. The thing that we have to keep in mind is that in order to make this a fair comparison, we also have to consider price, okay? And the price matters a lot because our utility may actually, our utility or our preference for the product doesn't necessarily change. If I hate go-karting, I'm still going to hate go-karting regardless of what the price is. But sometimes the price increasing or decreasing is motivating us to want to pursue a greater quantity demanded, or a lower quantity, okay? So that's really what's key. So here we'll want to consider the prices, okay? And if we look at, we'll kind of clean this up a little bit. If we look at the movies being a price of $10, okay, and go-karting being the price of $5, okay, now we're in a position to consider prices. So even though Pavit gets 30 utils from, going to the movies, the price of the movies is 3, so his marginal utility per dollar, okay, is 3. His marginal utility for the second time he's seeing the movie, he's getting 2 utils for every dollar that he's spending. Here it's 1, and here it's 0.5. Okay, for go-karting, which is a little cheaper, right? Go-karting is $5. He has lower utility for that, but we're going to say his marginal utility per dollar is 2. His marginal utility per dollar for the second go-kart ride is 1 because it is 5 utils, but it costs $5, so it's like a dollar for every util. And then here, we're getting into our fractions of, 2/5 or 1/5, like 0.2%, whatever, however you want to just kind of highlight it. Once we know that, we can also assume that marginal utility per dollar can help us with a couple of things, right? We can actually go shopping and imagine if we have a budget. Think of a budget line where if I only bought movies, how many could I get? If I only bought, which would be like 2.5, right? If I can only get go-karts, I could buy 5, and somewhere in between is where I'm going to maximize my utility. So if I have a budget of $25, I know that I can kind of go shopping, right? Which am I going to buy first? Well, wherever I have the higher marginal utility per dollar, right? So if I have the higher marginal utility per dollar here, I'm going to buy that first, and I've spent $10. Then I'm going to go here, and then I'm going to go here. I'm kind of indifferent between those two, and I've already spent my money, right? I bought 2 movies and 1 go-kart, and that's what I can combine for $25, okay? So I know that is going to maximize my utility because I know that the marginal utility per dollar for both go-karts and for movies are also equal to each other, okay? So I know that I've spent all my money, and I also have equal marginal utility per dollar when I go to spend that last dollar. The best way to think about this in terms of how this can change is by looking at a formula, which we'll look at in the next slide. But keep in mind, if your income were to increase, so say instead of $25, I had $50, okay? That is not going to change any of the numbers on this table, okay? It's not going to change my marginal utility. I still either like movies or I don't. I like go-karts or I don't. It's not going to change the price of the goods. That's set by the movie theater or by the go-kart people, right? So my income, the only thing that does is enable me to do more shopping, okay? If my my income increases, now I can keep going, right? I can buy, another go-kart ride and another movie and then another, and so on and so on and so on. So I will have a different combination of goods if my income were to change. If my income increases, likely, if it's a normal good, I'm going to have more of that particular good. If my income is decreasing, I'm going to have less. And of course, that will be flipped if it's an inferior good, okay? Something to pay attention to. Would not be surprised to have those kinds of questions on the AP exam. Okay, guys, so the key here is that there is a utility maximization formula, and that is really important to be able to work with, right? So first and foremost, let's just point out the utility maximization formula. You're looking for every single good that you're purchasing, pizza, oranges, apples, haircuts, whatever it is. As soon as you have put that last good, into your cart, right? And you are going to be purchasing, the last of this good and the last of that good. You want to ensure that you are, your marginal utility per dollar is exactly the same for all of the goods that you're purchasing, right? That they're equal to each other, okay? In the last example, we saw the marginal utility per dollar of movies was 2, and the marginal utility per dollar of go-karts was 2. So it fits, and they are maximizing their utility. If there's a situation where they're not equal, right? It's not 2, but instead it is, 2 and 4 or something like that. You're always looking to add more purchases. You're looking to purchase more, consume more of the one that's greater, right? If your marginal utility per dollar was actually higher for go-kart rides, you should actually go and get more go-kart rides. And when you do that, you purchase more, the marginal utility that's here, the marginal utility will actually decrease. Remember, marginal utility is not a static number. It's going to decrease as greater and greater quantities are. So if you're making a decision to buy more go-karts and by default fewer movies, you're going to eventually see the fractions kind of even out again, right? So you're looking, it's almost like a scale where you're looking to ensure that your marginal utility per dollar for every single good you're consuming is exactly the same. And if they're not, you are not maximizing your utility, okay? And the other thing, if you have a budget, you always have to maintain that you are within the budget that you have. So if you have $25, you can only purchase as many goods as that budget will allow. An increase in income only enables you to purchase additional products. The other thing that could happen, of course, is you could be maximizing your utility. Let's say you're maximizing your utility, and this is 2 equals 2, and all of a sudden something happens and the price were to change of one of the products, right? Because we're using this to really tell us a lot about the law of demand, we know that as the price decreases, people are likely to buy, higher quantity demanded. As the price, increases, people are going to buy less. So what happens to the price here is part of the pattern of the law of demand, right? If the price were to go down, okay, so all of a sudden there's a smaller number in the denominator, that is going to make this fraction greater, buy more of this product, okay? If the price goes in the other direction, then we have the opposite effect, right? So, we're kind of looking at price changes within utility theory too, because you could be happily along, kind of getting the same amount, or not the same amount, but this, a certain quantity of go-karts and a certain quantity of movies, and be maximizing your utility, but all of a sudden then the price can change, and then you would have to kind of refigure out your marginal utility per dollar. Okay, that would be different, which would lead you to purchase perhaps more go-karts or more movies, depending on where the fraction was greater. Okay, so let's look at this example here, and the key is for you guys to do this, not for me to put it here, so just kind of give this a try, but let's walk you through it a little bit, right? There's a couple things here. First of all, we have apples and we have oranges. This is pretty straightforward because apples are only $1 and oranges are only $2, so the math is really pretty straightforward. From total utility, okay, you need two things. One is you have to figure out marginal utility. You're working with this on a marginal basis unless you're asked questions about total utility. And you could be given marginal utility. You could be given marginal utility per dollar. So you have to really pay attention to what kind of data you have. But if you're given total utility, you're going to figure out marginal utility, and then you're next going to figure out marginal utility per dollar. Because the price is only $1, in this case, all you really need is your marginal utility. Marginal utility for every next apple, okay? In the case of oranges, you're looking to also figure out your marginal utility. In this case, because it's $2, you're just going to divide every single one of the marginal utility column numbers by 2, right? So you figure out your marginal utility, then you figure out what's your marginal utility per dollar, okay? And then you go shopping. In this case, you only have $7, okay? So you're going to keep on spending. Apples are $1 and oranges are $2, okay? And you can kind of figure that out and see ultimately what answer you get. Stop the video here and then we'll talk about the answer. Okay, if you've turned off the video there, you should come up with an answer of 2 oranges and 3 apples. Okay, so that is based on marginal utility per dollar, and you would purchase first the the apple, then maybe an apple and an orange, and then another apple and an orange, right? So you end up with 3 apples and 2 oranges. With that, you've used your $7, and you know that your marginal utility per dollar is equal. Note there may be other places where your marginal utility per dollar is equal, and of course, if it wasn't, we also assume, like, theoretically, you can buy fractions of goods, right? So 1 1/4 apple or whatever. But, in reality, that may be the case, but for for real purposes of just, for the model, you could do it that way. But, obviously, we're not going to buy fractions of oranges. Okay, guys, so let's look at this one problem together. This is one that is a good example of how a utility problem could come at you on the AP exam. And last year there was a utility question on the AP exam, so I'm not so sure they would do it again this year, but it does link to other topics, so it's very possible, especially the demand curve. You could also see supply this year, so we'll talk a little bit about that. But the total utility and the quantity for both apples and oranges, it's the same as that was on the last slide. So we've already figured out part of this problem. We kind of did it before, but we know that if apples cost $1 and oranges cost $2, and we've already figured out the marginal utility per dollar for each one of these goods, and we have $7, what would be the combination of apples and oranges, okay? And we basically said it would be 3 apples and 2 oranges, and that would be your total, right? That would be $7, okay? And then we're asked the next question: with the prices of apples and oranges remaining constant, assume that the consumer's income increases to 12, okay? Because prices are constant and marginal utility isn't changing, nothing changes to our formula, right, or to our numbers. What has changed is the income. So what will happen to the combination of apples and, oranges, right? We're going to be able to buy more with $12 than we were $7, but they want to know specifically how much. So if we go back to our data, right, if you have the data in front of you from the very, very last one, I know that when I bought the last apple and the last orange, my marginal utility per dollar was 10, but if I buy the additional kind of good that gives me the maximum marginal utility per dollar, I would buy the next orange, and then I would buy the next apple and the next orange, right? So I could buy an additional 2 oranges and an additional apple for a total of 4 apples and 4 oranges. So if my income was $12, I could buy 4 apples and 4 oranges, right? And I'm using my marginal utility to do that. The total utility the consumer will receive, if I know what my combination number is. I know I'm going to buy 4 apples and 4 oranges. I just have to add up the marginal utilities for each one of those, okay? And then lastly, with the last part, and definitely do this, try this so that you can do it, and we'll look at the answer in the next slide, but with the income that is now at 12, so that's staying constant, assume that the price of oranges changes, okay? Now this is going to give us a different scenario, and it's only for oranges. It's not for apples, and you could do a couple of things here, right? If we were given this new price for oranges, right, we could actually derive a demand curve, because we know when the price of oranges is $2, right, we know what the quantity demanded would be, right? When the price is $2 and the budget is 12, this person, whoever's consuming, would, sorry, I got the wrong number there, would be interested in 4 oranges, okay, in combination with apples. But if we were just doing a demand curve for oranges, we could actually derive a point on our demand curve by knowing when the price was 2, there would be a quantity of 4 that is actually demanded. If we increase the price, right, what we expect with the law of demand is that we're going to have a lower quantity demanded, okay? And this question becomes, what is the quantity demanded? Well, let's see what happens when we raise the price to $4. Instead of $2, now the price is $4. So we have our marginal utility. That hasn't changed, right? It's the same marginal utility we used the last time, right? 30 for the first one, 20 for the second one, 15 for the third, and so on. Now we're going to divide by 4 rather than 2, because for oranges we need marginal utility per dollar. The marginal utility per dollar for apples isn't changing at all. So we're going to want oranges, less, right? So kind of expect, because the price of oranges went up, that we're going to actually desire, fewer oranges in light of apples, okay? But figure that out, and then once you have that new combination of apples and oranges, right, you can do a few things. You can derive this on your demand curve, so we know a new point on our demand curve if the price were $4, and we can also figure out the exact quantity, and we can figure out our total utility at that new quantity, okay? So I'll put the answers on, but that's really kind of the rundown of utility theory. If you have any questions about this, definitely ask, and also make sure that you've completed the free response question that is in the AP Classroom.